Okay, in this video we're going to look at exponential growth and decay. So for exponential growth and decay, we look at the base. Okay, so if the base is greater than 1, then we have a growth. If b, the base, is between 0 and 1, okay, then it is a decay. Now, a growth is an increasing function. Going from left to right, and a decay would be a decreasing function going from left to right. So let's take a look at example 1. First thing we do is we go straight to the base. It's greater than 1, so we have a growth. Now to graph this, I'm going to go ahead and write down the parent function, which is going to be y equals 3 to the x. And notice that we have a vertical compression, which means that all the y values are going to get multiplied by a fourth. So graphing this, I'm going to start off with my horizontal asymptote, which is going to be y equals 0 for horizontal asymptote. So, using a dashed line. Now, if I plug 0 in here, 3 to the 0 power is 1. So my first point would be at 0, 1. But I have to multiply that times a fourth because there's a compression. So it's going to be 1/4. So when we input a 0 in here, this is 1, and 1 times a fourth is a fourth. So when x is 0, y is a fourth. Okay? 1. So if I go 1 unit over, if I input a 1, 3 to the first power is 3. 3 times a fourth is 3/4. So when x is 1, we're at 3/4. When x is 2, 3 squared is 9, and 9 times a fourth is 9/4. So when x is 2, y is 9/4. So 9/4 is going to be 2 1/4. Let's go the other direction. Let's go to -1. So if I plug a -1 in here, I get 1/3. And 1/3 times 1/4 is 1/12. So if I go over here, I'm going to be at 1/12. Alright, so I think I have enough points here. I'm going to draw along my asymptote. Good enough. For an exponential function, you need to have at least 2 points in order to make an exponential function. Okay, let's look at another example. Let's see. Okay, so notice we go straight to the b value. It's between 0 and 1, and so we have a decay. So let's graph it real quick here. Notice I'm not using a calculator, don't need to. Have a brain. Figure this stuff out. All right. what's the parent for this one? The parent for this one is going to be y equals 1/2 to the x power. So, starting off with our horizontal asymptote, which in this case again is y equals 0. Okay, and I'm going to go ahead and use pink. So when x is 0, 1/2 to the 0 power is 1. And then we have an a value of 5, so we have a vertical stretch. So 1 times 5 is 5. So when x is 0, y is 5. When x is 1, we have 1/2 to the first power, which is 1/2. 1/2 times 5 is 5/2, which is 2.5. All right, when x is 2, 1/2 to the second power, that would be 1/2 times 1/2, which is 1/4, and 1/4 times 5 is 5/4, or 1 1/4. So when x is 2, we're up 1 1/4. And we can see where this is going. I got at least 2 points here. I'm going to go along my asymptote. So notice it's a decay and it's a decreasing function. And let's just finish up with domain and range, shall we? So let's do the domain and range for this problem right here. Make sure we cover that here. So domain, I'm going to go ahead and use interval notation. So domain is left to right. So how far does it go to the left? Negative infinity. Because remember, there's no asymptote here to stop it. So it's going to go infinitely left. And how far does it go to the right? Again, we have an arrow going to the right. So it's going infinitely to the right. Range. Lowest to highest. Well, we have a floor here, an asymptote. So what is it approaching? It's approaching 0. And it never gets to 0. It's going to get closer and closer and closer to 0, but it never gets to 0. So we're using a parenthesis, not a bracket. And on the high end, it's going up infinitely. Okay, see you guys in class tomorrow, and we'll continue working on graphing exponential functions.